Hi, we're gonna present the problem situation of system for recycling electronic components by Alejandro, Andres, and Adrián. To commence, we made some research and found that in 2022, Mexico produced 1.5 million metric tons of electronic waste annually. This is around 12 kilograms of e-waste per capita. Based on the 3.5 annual increase in the electronic waste generation in Mexico, the projected amounts for the upcoming years are as follows: 2023, 1.55 million, 2024, 1.61 million, and 2025, 1.66 million metric tons. And you can see this on the table on the right. We also researched that Mexico's e-waste recycling combines formal initiatives like corporate programs with an informal sector that provides economic opportunities but lacks environmental safeguards. Only 10% of e-waste is recycled through regulated channels due to unclear responsibilities, regulatory inconsistencies, and low public awareness. Addressing these challenges requires a unified framework, stronger public participation, and collaboration among government, private sector, and civil society. E-waste regulations aligns with SDG number 11, Sustainable Cities and Communities, by reducing urban pollution, protecting ecosystems, and fostering healthier environments. And the SDG number 12, Responsible Consumption and Production, by promoting resource recovery, sustainable designs, and reducing waste. Proper regulation minimizes environmental harm and recycles valuable materials and supports sustainability at local and global levels. The Whetstone Bridge is a circuit for measuring unknown resistances by balancing two legs of a bridge invented in 1833 by Samuel Hunter and popularized in 1843 by Charles Whetstone. It uses four resistors, two known, one unknown, and one adjustable, arranged in a diamond shape with a voltage source and a galvanometer. When balanced, the unknown resistances is calculated as R1 over R2 equals Rx over R3. And here you can see some applications: strain gauges, temperature measurement, sensors, calibration, and impedance testing.
So during the development of the situation problem, we created a Wheatstone bridge, as shown here in LT Spice, which is an electrical circuit that consists of four resistors arranged in a diamond shape, in which that diamond shape creates two branches, each one having two resistors in series. And in each branch, between the two resistors, there are nodes that are connected by a galvanometer, in which it will detect the differences of nodal voltage between them. That way, it creates a value of a voltage that will help us for a mathematical model that help us find the unknown resistance of the resistor that we are trying to analyze. That way, we will try to know if the resistor it is still capable of being recycled or not.
So here we have test results. When our test is less than our Rx, we have that the node B, where our test is involved, is less than the node A. When our test is higher, the node B it's also higher. When our test is equal to 0, we have that the node B will be 0. And when our test tends to infinity, we have that we get close to double the value of node A. This is very important for the conclusion.
So during our conclusion, we created a mathematical model for our test, which is a resistor that we are analyzing. And in here, we use the currents of each branch of the diamond shape that has the same voltage but different equivalent resistance as shown, which it gives two different currents. And by using those currents, we use for each node, we use Ohm's law to combine it with the resistors that are in the upper part of the diamond shape, and that way we will try to create another type of equation that'll help us find create another equation regarding the equation of V out as shown in the last step. And in there, by moving out and trying to substitute values, we created a final equation that is our test equals to Rx divided by V out divided by the voltage source plus 1/2 minus Rx.
So, as we can see here in the conclusion, after getting to the mathematical model required, we can assume that with only a multimeter to get the voltages out of node A and node B of our system, we're capable of getting any resistance life usage and if it's still correct. Also, assuming that we can Thevenin any system, we can also tell that if a system is working correctly or not, depending on the input of that system and the Thevenin resistance. Thank you.